Hello everyone, welcome to this video lesson. In this video lesson, we are going to talk about a theorem called something like parallel axis theorem. This is about moment of inertia. First of all, what is the moment of inertia? It is a physical quantity which tells you how difficult it is to rotate a body or how easy it is to rotate a body. Mean to say, if moment of inertia of a body is small, it is easy to rotate a body. We need less torque to rotate the body. If moment of inertia is large, it is difficult to rotate the body and we need more torque. Moment of inertia is mathematically defined as sigma mr square. What I mean by sigma mr square is, sigma is summation, m is the mass of the particle, r is the distance of that particle from the axis of rotation. That means there are so many particles in a body. Each particle will have a mass. It has some distance from the axis of rotation. So I have to do r square multiply with m, and I have to do with all the particles. Let's say, and we have to add all the moment of inertia of each particles together. Then I will get the total moment of inertia of a body. So it's very clear, moment of inertia depends on axis of rotation. Why? R is the distance from the axis of rotation, where R is the distance of the particle from the axis of rotation. So whenever axis of rotation changes, R value changes. Therefore, moment of inertia also changes. Thus, every time calculating the moment of inertia right from the scratch, when you change the axis of rotation, is practically very difficult. To solve that problem, we have a parallel axis theorem. We have parallel axis theorem. This theorem helps you to find the moment of inertia of the body about one axis if you know the moment of inertia of the same body about a parallel axis. Let us try and understand what is it is. I'm not going to give the definition right now. I'll give it a little later. At the end of this video lesson, I'll give you the definition. Let us consider there is a body like this. Let us assume this point is center of mass or center of gravity. If the body is a regular body, both of them coincides with each other. And I know the moment of inertia of this body about this axis. Let me call it like Ig. It's called center of gravity. We can calculate it using the concept of integration. I have done for a ring, for a disc, and for a thin rod in the previous video lessons, that how do you calculate the moment of inertia of a body about a given axis. If you would like to know, please refer that video lesson. But in this video lesson, I am taking it for granted that I have already calculated it. I know the value of this Ig. Now my aim is, I want to calculate the moment of inertia of the same body about another parallel axis, that is I. Let me also assume these two axes are having a perpendicular distance of separation r. So I know Ig. I want the moment of inertia of the same body about a parallel axis who is at a distance r from the first axis, where Ig is the moment of inertia of that body about an axis passing through the center of gravity of that body. I need to calculate it. I need to do it. Now let us consider a particle somewhere here. Let that particle is having a mass m. For the sake of just for the sake of a reference, let me name this point as O. Let me name this point as something like A. Let me name this point as something like B. So this point, like what I said, M, is at a distance AB from the axis of rotation. Now I can write moment of inertia of body about its center of gravity or center of mass, assuming the body is a uniform body, center of gravity and center of mass coincides with each other. Ig equal to m ab square. Let us assume there are multiple particles. For each of them I have calculated, so I am adding a sigma m into ab square. Now the same body or the same point from the parallel axis is at a different distance, say OB, because I have assumed this distance as B. So for the same body, moment of inertia about the parallel axis is I equal to sigma m into OB square, this distance. Now I need to express this OB square in terms of the available data, something like Ig. So what I will do is, I will just extend this line, and from here I will draw a perpendicular bisector. Mean to say, here the angle is 90 degree. Let me name this point as C. Now I can see there is a right angle triangle OBC. Using the Pythagoras theorem, I can write OB square as OC square plus BC square. But I know OC is nothing but equal to OA plus AC. Let me substitute that. OC is OA plus AC whole square plus BC square. Writing A plus B whole square, OA square, AC square, 2 OA AC plus BC square. But if you see, there is another right angle triangle as triangle ABC is also a right angle triangle. I can again use this Pythagoras theorem. I can write AB square as AC square plus BC square. In the above equation I can see AC square and BC square. Instead of that I can write this AB square. That implies OB square becomes OA square. Instead of AC square plus BC square, AB square. Remaining terms are as it is, 2 OA and AC. Now knowing the value of OB square, I can substitute in the equation for I and write an equation of that I. Let me write. That implies as moment of inertia about a parallel axis is sigma m into OB square. But I know OB square already. Let me substitute. I equal to sigma m, instead of OB square, OA square, AB square, 2 OA and AC. Then multiply with sigma m for each term. Sigma m into OA square, sigma m into AB square, sigma m into 2 into OA into AC. I have just expanded the terms. That implies moment of inertia is sigma m. OA is the distance between, perpendicular distance between O and A, that we are assuming it like r square. Sigma m into AB square is nothing but the moment of inertia of the same body about an axis passing through center of gravity. That's nothing but equal to Ig plus sigma m to OA and AC. But if you see, sigma m is the mass of the body. OA or AC is the distance of the body from the axis of rotation. The product of mass of the body with distance from center of mass is called moment. There is a concept in center of mass that the algebraic sum of moments of any body about its center of mass is equal to 0. That means each moment will be cancelling the other moment because particles are uniformly distributed. What happens is automatically this last term becomes 0. So substituting that, I'll get an answer as I as Ig plus sigma m r square. Sigma m can be written like mass of the entire body, r square plus 0. That implies I equal to Ig plus mr square. This is what do you mean by parallel axis theorem. So what it tells you, the moment of inertia of the body about an axis I is equal to the sum of moment of inertia of the same body about an axis passing through center of gravity and product of mass of the body with the square of the distance from the axis of rotation. It means to say, if I know Ig, if I know m, and if I know r, I can calculate the I without going for the elaborate integration or a tough process to find the moment of inertia of any body. That's how parallel axis theorem helps you in making and in determining moment of inertia easy for you. That's it. So for your clarity's sake, let me define once again. Moment of inertia of the body about any axis I is equal to sum of moment of inertia of the same body about an axis passing through center of gravity and the product of mass of the body with the square of the distance from the axis of rotation. Thank you for watching. Keep coming back to this IIT-JEE and NEET Physics video lessons source for more and more video lessons. Thank you.